NASA's SLS, the giant leap for deep space exploration rocket. Hello, everyone. Friends, you won't believe what's happening right now in the world of space technology. We are standing at the threshold of a new era, and this changes everything. For decades, we've dreamed of reaching the furthest corners of our solar system, but the sheer size of the equipment needed was always the bottleneck. Well, what you're about to see is incredible. The NASA Space Launch System, SLS, isn't just another rocket. It is a game-changer that is set to enable 6 mind-blowing missions over the next 30 years. Pay close attention to this. We aren't just talking about floating in low Earth orbit anymore. We are talking about landing humans on the moons of Mars and sending twin spacecraft to the icy giants, Uranus and Neptune, in a single shot. This is bigger than you think. And to put it simply, the SLS is the heavy lift champion the universe has been waiting for. The powerhouse. Why SLS is unmatched. Stay with me, because the numbers here are truly surprising. To understand what is going on, we have to look at the raw power of this machine. The SLS Block 1B can haul a staggering 130 metric tons, MT, to low Earth orbit. But the real magic happens in its fairing, the giant nose cone at the top. With a diameter of up to 8.4 meters, it's like having a flying warehouse. This massive space allows NASA to launch entire habitats and telescopes as single, integrated units. This part is really important. Instead of building complex puzzles in space, we can test everything on the ground and send it up ready to go. Keep watching, because this capability is what makes the following missions possible. Payload capacity, 130 metric tons to LEO. Direct trajectories, high-energy boosts for faster travel to deep space. Safety first. Reduced on-orbit assembly means fewer things can go wrong. Destination Phobos. The Mars base camp. Things are about to get crazy when we talk about our neighbor Mars. Instead of heading straight for the dusty surface, scientists are looking at its moon, Phobos. Just imagine a base camp orbiting only 6,000 kilometers above the Martian surface. What do you think about this? By landing on Phobos first, astronauts can teleoperate rovers and drones on Mars in real time with zero lag. I'm really curious what you think. Would you rather land on the red planet directly or start this high base camp? According to an amazing study, this mission only requires 4 SLS launches. Using nuclear thermal propulsion, NTP, with an efficiency, ISP, of 900 seconds, we could get a 42.3 MT crew habitat all the way to the Martian vicinity. It's a literal stepping stone to the stars. Oceans of ice, Europa, and the outer giants now. Let's go even further. You need to see this. Europa, Jupiter's moon, hides a liquid ocean beneath its ice. The SLS can inject 27.4 metric tons toward Jupiter on a 4.8-year journey. The plan? A 1 metric ton rover powered by a nuclear battery, RTG, to investigate geysers where water might be escaping from the interior. But wait, it gets even more interesting. Have you ever wondered why we don't visit Uranus or Neptune more often? It's because they are incredibly far away. However, the SLS is so powerful it can launch 2 flagship-class spacecraft at the same time. One would arrive at Uranus in 16 years, and the other at Neptune in 18 years. Tell me in the comments, would you wait nearly 2 decades for photos from the edge of the solar system? In this context, the scientific return would be the greatest in human history. The all-in-one Mars sample return. Watch this carefully, because this is where the SLS simplifies the mission of the decade. Currently, getting samples back from Mars is like a complex cosmic dance involving multiple rockets and orbital handovers. But with the SLS, we can do an all-in-one mission. By using the massive lift capacity of the SLS Block 1B, we can send a heavy lander that carries its own Mars ascent vehicle, MAV. This ship lands, grabs the rocks, and blasts straight back to Earth. No mid-space. Transfers, no extra launches. Does this change your opinion on how hard space travel is? With a 7 metric tons launch margin, there's even room to bring back more samples or extra science gear. This is just the beginning of a more efficient way to explore. A telescope on Phobos and the lunar return, the most interesting part of the topic is how we can use these worlds as platforms. Surprising as it sounds, the SLS could place a 7.0 metric ton telescope on the North Pole of Phobos. Without Earth's atmosphere in the way, this eye in the sky could monitor Martian weather in deep space with unprecedented clarity. Finally, we have the Lunar South Pole mission. By 2030, a 2-launch campaign could put humans back on the moon. Friends, we are talking about a lander that stays for 5 days, exploring the icy shadows of the lunar south. If you're enjoying this, don't forget to like, and please don't forget to subscribe, friends, for more tech updates. What is going on right now is a revolution. The SLS isn't just a rocket. It's the bridge to our future as a multi-planetary species. Support the channel by liking before we wrap up. To learn more about the technical specs of these missions, visit talkteddertech.com. Thanks for watching. See you in the next video, because there's more coming and you're not ready for this next update. Until next time,